Hello everyone, this video is presented by Zoom in Data, where learning meets real projects. In this video, I am presenting an overview of a simple DevOps project that I have already implemented using Azure DevOps and Azure Web App. The objective of this project was to understand and demonstrate the complete DevOps lifecycle, starting from source code management and ending with automated deployment to the cloud. To begin this project, I created a new project in Azure DevOps, which serves as a central platform for managing the entire DevOps workflow. While creating the project, I defined the project scope, visibility, version code settings, ensuring it was properly structured for collaborative development and automation. Once the project was created, Azure DevOps automatically provisioned the core services such as repositories, pipelines, which form the foundation for implementing CI and CD. This project setup allowed me to manage source code, configure pipelines, and integrate cloud services within a single unified environment. Overall, creating the Azure DevOps project was the first and most important step, as it established the base for implementing the complete DevOps lifecycle. After creating the project, I used Azure Repos as a source code management system for this project. Azure Repos provided a Git-based repository where all project-related changes were stored in a centralized and version-controlled manner. It allowed me to track code changes over time, maintain different versions, and ensure that latest updates were always available to the pipeline. Azure Repos also played a key role in automation, as every commit made to the repository acted as a trigger for the CI/CD pipeline. Overall, Azure Repos helped maintain code consistency, traceability, and seamless integration with the rest of the DevOps workflow. Once the source code was managed in Azure Repos, the next step was setting up continuous integration using Azure DevOps pipelines. The CI pipeline was configured to automatically trigger whenever a change was committed to the repository. Its main purpose was to validate the application by running the build process in the consistent environment, ensuring that every change was verified before moving forward. By automating the build process, the CI reduced manual effort and helped identify issues early in the deployment lifecycle. Overall, the CI pipeline ensured that the application was always in a build-ready state and formed the foundation for continuous deployment. In this project, CD was implemented using Azure DevOps pipelines integrated with Azure App Service. After a successful build in pipeline, the same pipeline handled the deployment of the application directly to Azure Web App. This integration ensured that every validated change was automatically delivered to the cloud environment without manual deployment. By using Azure DevOps pipelines for deployment, the entire process from code commit to cloud deployment was fully automated. This is where continuous deployment was achieved in this project. To enable deployment from Azure DevOps to Azure, I configured a service connection. This service connection acts as a secure bridge between Azure DevOps and Azure, allowing the pipeline to authenticate and deploy resources safely. By setting up the connection, Azure DevOps was granted the required permission to deploy the application to the Azure Web App. This Azure ensured that all deployments were performed securely without exposing sensitive credentials to the pipeline. The service connection played a critical role in enabling seamless and automated continuous deployment in this project. For deploying and hosting the application, I configured a web app using Azure Portal. During the creation of the web app, I selected the appropriate subscription and resource group to logically organize the application resources. I then chose the runtime environment. Based on the application requirements, selecting Python as the runtime along with the Linux operating system. This ensured compatibility and stable execution environment for the application. A suitable pricing plan was selected to support the project requirements while keeping the setup cost effective. Once the web app was created, I configured it to act as a deployment target for the DevOps pipeline. After deployment, the application became accessible through a public URL, confirming that web app was configured and running successfully. That brings us to the end of this DevOps project overview. If you are interested in gaining hands-on experience with real-time DevOps projects like this, grab the opportunity with Zoom in Data. Thank you for watching.